In a universe teeming with countless galaxies, stars, and planets, the question lingers in the depths of our collective imagination. Are we truly alone in the vast cosmic expanse? Join us on an extraordinary odyssey as we embark on a quest to unravel the enigma of extraterrestrial life, venturing into uncharted territories where the boundaries of possibility blur and the whispers of distant civilizations beckon. Brace yourself for a mind-bending expedition that will challenge everything you thought you knew about our place in the cosmos. For the truth we seek may forever reshape our understanding of existence itself. Is mankind alone in the universe? Or are there somewhere other intelligent beings looking up into their night sky from very different worlds and asking the same kind of question? Are there civilizations more advanced than ours, civilizations that have achieved interstellar communication and have established a network of linked societies throughout our galaxy? Such questions, bearing on the deepest problems of the nature and destiny of mankind, were long the exclusive province of theology and speculative fiction. Today, for the first time in human history, they have entered into the realm of experimental science. Movements detected. From the movements of several nearby stars, we have now detected unseen companion bodies in orbit around them that are about as massive as large planets. From our knowledge of the processes by which life arose here on the Earth, we know that similar processes must be fairly common throughout the universe. Since intelligence and technology have a high survival value, it seems likely that primitive life forms on the planets of other stars, evolving over many billions of years, would occasionally develop intelligence, civilization, and a high technology. Moreover, we on Earth now possess all the technology necessary for communicating with other civilizations in the depths of space. Indeed, we may now be standing on a threshold about to take the momentous step a planetary society takes but once, first contact with another civilization. In our present ignorance of how common extraterrestrial life may be, any attempt to estimate the number of technical civilizations in our galaxy is necessarily unreliable. We do, however, have some relevant facts. There is reason to believe that solar systems are formed fairly easily and that they are abundant in the vicinity of the sun. The technique to detect life. The only technique we have at present for detecting the planetary systems of nearby stars is the study of the gravitational perturbations such planets induce in the motion of their parent star. Imagine a nearby star that over decades moves measurably concerning the background of more distant stars. Suppose it has a non-luminous companion that circles it in an orbit whose plane does not coincide with our line of sight to the star. Both the star and the companion revolve around a common center of mass. The center of mass will trace a straight line against the stellar background, and thus the luminous star will trace a sinusoidal path. From the existence of the oscillation, we can deduce the existence of the companion. Furthermore, from the period and amplitude of the oscillation, we can calculate the period and mass of the companion. The technique is only sensitive enough, however, to detect the perturbations of a massive planet around the nearest stars. The Barnard star. The single star closest to the Sun is Barnard's star, a rather dim red dwarf about 6 light-years away. Although Alpha Centauri is closer, it is a member of a triple star system. Observations made by Peter van de Kamp of the Sproul Observatory at Swarthmore College over 40 years suggest that Barnard's star is accompanied by at least 2 dark companions, each with about the mass of Jupiter. There is still some controversy over his conclusion, however, because the observations are very difficult to make. Perhaps even more interesting is the fact that of the dozen or so single stars nearest the Sun, nearly half appear to have dark companions with a mass between 1 and 10 times the mass of Jupiter. In addition, many theoretical studies of the formation of planetary systems out of contracting clouds of interstellar gas and dust imply that the birth of planets frequently, if not inevitably, accompanies the birth of stars. Evidence of life. Other evidence of the origin of life comes from the geological record of the Earth. Thin sections of sedimentary rocks between 2.7 and 3.5 billion years old reveal the presence of small inclusions 1/100th of a millimeter in diameter. These inclusions have been identified by Elso S. Barkhorn of Harvard University and J. William Schaff of the University of California at Los Angeles as bacteria and blue-green algae. Bacteria and blue-green algae are evolved organisms and must themselves be the beneficiaries of a long evolutionary history. There are no rocks on the Earth or the Moon, however, that are more than 4 billion years old. Before that time, the surface of both bodies is believed to have melted in the final stages of their accretion. Thus, the time available for the origin of life seems to have been short, a few 100 million years at the most. Since life originated on the Earth in a span much shorter than the present age of the Earth, we have additional evidence that the origin of life has a high probability, at least on planets with an abundant supply of hydrogen-rich gases, liquid water, and sources of energy. Since those conditions are common throughout the universe, life may also be common. Intelligence and technology have developed on the Earth about halfway through the stable period in the lifetime of the Sun. There are obvious selective advantages to intelligence and technology, at least up to the present evolutionary stage, when technology also brings the threats of ecological catastrophes, the exhaustion of natural resources, and nuclear war. Barring such disasters, the physical environment of the Earth will remain stable for many more billions of years. The number of individual steps required for the evolution of intelligence and technology may be so large and improbable that not all inhabited planets evolve technical civilizations. It is also possible, some would say likely, that civilizations tend to destroy themselves at about our level of technological development. On the other hand, if there are 100 billion suitable planets in our galaxy, if the origin of life is highly probable, if there are billions of years of evolution available on each such planet, and if even a small fraction of technical civilizations pass safely through the early stages of technological adolescence, the number of technological civilizations in the galaxy today might be very large. Interstellar communication. To intercept such signals, we must guess or deduce the frequency at which the signal is being sent, the width of the frequency band, the type of modulation, and the star transmitting the message. Although the correct guesses are not easy to make, they are not as hard as they might seem. Most of the astronomical radio spectrum is quite noisy. There are contributions from interstellar matter, from the 3-degree Kelvin background radiation left over from the early history of the universe, from the noise that is fundamentally associated with the operation of any detector, and from the absorption of radiation by the Earth's atmosphere. This last source of noise can be avoided by placing a radio telescope in space. The other sources we must live with, and so must any other civilization. There is, however, a pronounced minimum in the radio noise spectrum. Are we alone in this vast universe? The search for extraterrestrial life has ignited a fire within us, propelling our imaginations beyond the confines of our pale blue dot. With every tantalizing discovery and tantalizing clue, our conviction deepens, and the whispers of otherworldly beings grow louder. So let us continue this cosmic quest, fueled by an insatiable curiosity and an unyielding desire to unravel the mysteries of the cosmos. If you found our video informative, kindly subscribe to our channel so you won't miss out on our videos.